Hello guys, welcome back to my channel Algorithm Minds. My name is Hasan Khurram and in this channel I teach programming skills in Python, MATLAB or R programming. I also teach theoretical concepts as well as practical programming skills in data analysis, statistical analysis, data science or machine learning. So if you're a person who wants to learn programming such as Python, MATLAB or R from beginning, or you are a person who wants to excel his career in data science, I request you to subscribe to my channel and hit the notification bell icon button. As I have stated earlier that I'm going to produce series of videos on statistical analysis in Python. So for today's lecture, I'm going to discuss about the confidence intervals and inferential statics, and we are going to exercise those concepts with the help of Python programming. So it will be a highly resourceful video for you. So before we will first discuss about the theoretical aspects. After that we will go on and do the practical programming skills, where we will actually teach you how to exercise those concepts in Python programming. So inferential statistics is a branch of statistics that involves making prediction or inferences about the population based on sample data. So you, for example, you have a data set that is huge in quantity. Let's say like it has like 100,000 values, and you take out some 50 values randomly. Now you want to make predictions, or you want to estimate the parameters of the population based on that sample data. That is quite in less in amount number. This include hypothesis testing, where we test a hypothesis about a population parameter based on sample data and make a decision about whether to accept or reject the hypothesis. One of the key tools in inferential statistics is the confidence interval. So what is actually called confidence interval? Confidence intervals are essential in statistics to quantify the uncertainty around an estimated parameter from a sample. So when you can calculate the mean of a sample, you may want to understand how this compares to the mean of the broader population. However, due to sampling, the two means, which is the means of sample and the mean of the population, they likely won't match exactly because of the size difference and the values that are being used to calculate the mean. This is where confidence interval comes into play. They provide a range of values within which we can reasonably expect the true population parameter to lie, given a certain level of confidence. So as discussed earlier, the confidence interval help us estimate the range in which the population parameter, mean, proportion lies. The confidence level associated with the confidence interval represents the probability that the interval contains the true population parameter. Common confidence levels include 90%, 95%, 99%. So it means that, for example, let's say with the 95% confidence level, we are 95% sure that the range we are getting for estimation parameters such as mean from sample is the true representative of the population parameter with a 95% confidence level. A wider interval implies greater certainty, while a narrow one suggests more precision. Factors like sample size and variability influence the width of confidence interval. So enough for the theoretical jargon. Let's move on and actually exercise those concepts in Python programming. So for that purpose, I'm going to first import two important libraries for our today's lecture. The first one is NumPy, the second one is SciPy. So I'm going to use this Python statement here, import NumPy as NP, then informs SciPy import stats. So I'm from library SciPy, I'm importing a module stats, and here I'm importing NumPy library as NP, and as NP is analyze. For example, whenever we want to actually call the NumPy library, we are going to use its alias, that is NP. So now you have imported your libraries. Let's move on and actually let's create a data set that represents the population. Then from that data set, we will randomly select values that will represent the sample data sets. So first of all, I'm going to use this Python statement here, np random.seed 42. This Python statement actually help us for reproducibility. This will ensure that whenever the script is run again and again, we will have the same randomly distributed data points, irrespective of how many times that script has been run, or irrespective of on what laptop, on what computer this script has been run. So it helps us actually reproduce the same results whenever the script is run. So now you understand this concept of np random.seed. Now let's move on and actually create the data set of our population. So for this purpose, I'm going to initialize a variable named population. I'm going to assign value by calling the NumPy library and calling its method normal. And I'm passing 3 input arguments. The first one is log, the second one is scale, and the last one is actually size. So I will discuss you one by one what does the input argument represent. So the first input argument is LOC is equal to 50. So log, it means is equal to 50. It means we are providing that whatever the randomly distributed data points are generated, it should have a mean of 50. Then we have scale is equal to 10, represents the standard deviations. That is actually how the points deviate from the mean. So we are assigning its value to 10. Then finally we have size. So in our case, we are interested in creating 100,000 data points for our population. So that's how you actually can create a randomly distributed data point that represents a population. Once you have actually created your population, now we want to actually take a sample, and the sampling technique I'm using in this tutorial is called random sampling. I have made a detailed video where I will teach you about the different sampling techniques in depth. So I will put the link in the description for you, so you can actually watch that video. It is a highly resourceful video. So if you are new to statics and you don't have the idea of sampling or sampling techniques, I suggest you to go and watch that video. I will put the link in the description for you. So once I have made my population, I'm going to take some data out of it and I will term this as sample. So for this purpose, I'm going to initialize a variable named sample underscore data, and then I will call NumPy method choice. And then I will pass the input argument. The first input argument is actually the population from which we actually want to extract sample. And then I also want to define the size of that sample size. For that case, I'm interested in only the 50 values out of those 100,000 values to be taken as a sample. Then I have assign another input argument, which is replace is equal to false. It ensures us that once a point has been selected by this random choice method, it will not be selected again. Okay, so one data point will only be selected only one time. It will not be selected 2 times or 3 times. So the replace is equal to false. That's what it actually helps us ensure that. Let me just run this block of code for you. Now once you have done that, let's move on and actually calculate the mean of sample data and population data. And it's quite easy to do. You will simply call NumPy library, and then you're going to use this method mean, and then within those round brackets you are going to pass the input argument, which in our case is the sample data and the population. So you have done that. We are going to initialize variable named sample mean and pop mean. Pop means population mean, and we are using this method to actually calculate the mean. So now you have calculated the mean. Now let's move on and actually calculate the standard deviation of the sample. Please keep that in mind, that we are calculating the standard deviation of the sample. And in order to calculate the standard deviation of the sample, I'm going to initialize a variable named sample underscore std. Then I'm calling NumPy method std, and I'm passing 2 input arguments. The first is actually the data for which we actually want to calculate the standard deviation, and the second one is actually DDOF, which is delta degree of freedom is equal to 1. This is actually specifies the formula through which we actually want to calculate the standard deviation. So when you have a sample from a population, you can use the formula with DDOF is equal to 1. This formula divides by n minus 1, where n is the number of observation in the sample. The adjustment is called Bessel correction and corrects the bias in the estimation of population variance and standard deviation. So when you are actually calculating the standard deviation of population, you will set DDOF is equal to 1. Once we have actually calculated the standard deviation of the sample data, let's move on and actually calculate the confidence interval. So this purpose, I'm going to initialize a variable named confidence underscore interval. Then I'm going to use the library module from the library SciPy, whose module is stats. Then I'm going to use this function norm interval method. and I'm going to pass number of input argument. The first input argument is 0.95, which actually represents the confidence level we want for the calculations. In our case it's 95%, so whatever the range we are getting, we would be 95% confident that this estimate, which in our case is the estimate of the mean, because we are estimating the sample mean and we are trying to project the mean to the population mean and see that how well this sample mean actually estimates the population mean. So whatever the range we will be getting, we will be 95% sure that this estimate is 95% with 95% confidence is the true representative of the population mean. So that's what we have, like 0.95 here. And then the second input argument is actually the sample mean we have actually calculated earlier. LOC is equal to sample mean. Then the last parameter is scale, which is actually the standard error of the mean, which is calculated by sample standard deviation divided by the square root of number of elements in the sample data, which is all. Then this complete term, sample standard deviation divided by square root of sample data, is termed as standard error of mean, which is calculated as the sample standard deviation divided by the square root of the sample size. The standard error measures the accuracy with which the sample mean represents the population's mean. So once we have declared our Python statement here, let me just run this block of code for you, and after that I'm just displaying the values by using print function and using sample mean, population, and printing the values of sample mean, population mean, sample standard deviation, and our confidence interval, which is actually the range in which the estimate will represent the population mean. Let me just run it block of code for you. Now you can see that the sample mean is actually 50.6028, and we have population mean 50.6028,609, and sample standard deviation is 10.4501, and the confidence interval for the population mean is from 47.706 to 53.4999, which we see that the population mean, which is actually 50.6028, do lie within that interval. So that's how you can actually calculate the confidence interval through a sample. Then let me recap you. We created a population, then we extracted a sample by using random sampling method. Then we actually calculated the confidence interval, that actually this is actually the estimate of how well this sample mean actually represents the population mean. So that's how you can actually calculate the sample mean. So let me, if I change this value from 0.95 to 0.99, so we want to be more precise in that case. When I run this code here, now you can see that we have a different confidence interval. So that's how you can actually do it. So now the range has increased because we want to be more precise that this our sample estimate should represent the true estimate of the population. So that's it for now. I hope this tutorial has been helpful to you. If you have any questions regarding theoretical aspects as well as the practical programming aspect in this tutorial, feel free to write down your questions in the comment section. I will be happy to help you out. And just a reminder, as I stated earlier, that I will be posting more videos related to statistical analysis in Python, which include regression analysis, plotting, correlations, and so on. So I request you to subscribe to my channel, hit the notification bell icon button. Thank you for joining me.